Hello everyone, welcome back to my YouTube channel. In this particular video, we'll be looking into a new topic from Big Data Analytics, which is content-based recommendation systems. So let's have an overview of this particular topic. It recommends items based on the user preferences. You might have observed one thing: whenever you purchase a product from any e-commerce website, you will get similar product recommendations. Now this is because you, being a user, has interacted with that particular product. That means that is your preference for that particular moment. Hence, similar products would be shown to you. So as I said, here the user's preference is taken into consideration. The recommendation engine in this particular type of recommendation system will store the characteristics of the items that user has interacted with and will use that characteristics for further recommendations. Now this type of recommendation system can be used in big data with the help of distributing the data into chunks and processing those chunks in a parallel manner. So here the major technique that is used is the content analysis. Whatever content the user is interacting with, that particular content and feature is very much important in this particular case. Now in this type of recommendation system, we majorly use Cosine and Jaccard similarity to measure the similarities between two different products or between the user's interest and a particular product. Now the content-based recommendation system is majorly used in e-commerce websites and in media sector. So now I hope that you might have got an overview of what this content-based recommendation system actually means. Now that you have got an overview, now let's see the techniques that this type of recommendation system uses to gather the data or the signal from the user. So there are two types of techniques. The first technique is implicit data or implicit signal. So this is inferred from the user's behavior. That means here user's input will not be taken directly, but it will be taken and interpreted indirectly. For example, if you are watching a particular video on YouTube for a longer period of time than usual, or let's say if you watch a particular video more than once, or you more frequently rewind the video to watch it, then in that case, the recommendation engine assumes that the user is greatly interested in this particular video and similar types of such videos. So I hope the example is clear to you all. Here, the user is not directly giving the input, but it is assumed indirectly. All of these sources. Now there is a drawback for this. Just imagine if you click a particular video which you may or may not be interested in, and all of a sudden someone calls you for some or the other work, and you just keep that video on and went for doing that particular work. Then in this particular case, the recommendation engine assumes that you are very much interested in it, and now it has saved all the keywords from that video so that it can recommend you similar videos in future which you may or may not be interested in. So hence it often generates noisy recommendations, which means the recommendations in which you might not have interest. So this is the first technique. I hope it is clear to you all. Now let's move on to the next technique, which is explicit data, or it is also called as explicit signal. In this particular technique, the data is collected by the user's preference. Here the users themselves will state the input, and that input will be given to the recommendation engine. For example, hitting like to a particular YouTube video, sharing it with your friends, or subscribing the channel just after watching that particular video. Now if a user genuinely likes the video, then only he or she will like it, share it and subscribe it. So here you can see that the user is providing the input, and this input will only be taken by the recommendation engine. Now there is an advantage of this, and the advantage is that the recommendations that will be made in future to the user will always be reliable and will be the most accurate, because here the user is directly giving the input. So I hope this type of technique is clear to you all. Now in content-based recommendation system, both of these techniques plays an important role. Now that we have got a very brief idea of the content-based recommendation system, now let's have a look at the example to clear all your doubts. So let's say we have a user. and this particular user is watching a video on YouTube. Now every item that the user is interacting with will be having its item vector. Now in this particular case, the user is interacting with the video, hence there will be an item vector associated with that particular video, and here is that item vector. So since this is the item 1, hence we'll state it as item 1 vector information, and the video is about matrix multiplication using MapReduce. So the features and the keywords will be extracted from this particular video, and the features or the keywords are matrix multiplication, MapReduce, big data analytics, and the name of the channel, that is at a glance. All these important keywords are going to play an important role for recommendations. These keywords will be stored in the form of an array or the vector, which will contain the importance score. So I hope this is clear to you all. Every item will be having its own item vector. Now since the user is watching this particular item or video, the keywords or features that the user is actually interacting with will be stored in the user profile, which is called as user vector information. Every user will have their own user vector information. In this, the relevant keywords or features that the user has interacted with in the form of watching the video will be stored in a form of array or vector, which will contain the importance score of that particular keywords. And this user vector information is going to play a huge role for recommendations. Now I hope these two things are clear. Now let's say there is one more video on YouTube. Now as I said, every video or every item will have its own item vector. So here the item vector will be called as item2 vector. Now this video is about MapReduce in Hadoop. The keywords and important features in this video are MapReduce, Hadoop Big Data Analytics, and at a glance. That is the channel in which this particular video is present. Again, all this information will be stored in the form of array or vector with their importance score. Now you can see that based on the information that is present inside the user vector and the information that is present inside the item2 vector, the similarity will be measured. Now for measuring the similarity, we have many types of similarity measures. For example, cosine similarity, Jaccard similarity. Out of the similarities, we need to choose one of the similarity and find out whether the user's vector information is actually similar to the item2 vector information. Now in this case, the keywords MapReduce, Hadoop, Big Data Analytics is already present inside the user vector information. Hence you can say that this video is actually similar to the previous video that user has interacted with, and hence this new video will be recommended to the user. The video might also get recommended even if it is not of the same channel. So now I hope how content-based recommendation system works is clear to you all. This is a very simple example, but in reality on YouTube, more than billions of videos are present. Then in that case, the complexity increases. Now that we have seen an example, now let's see the similarity measures that are used in content-based recommendation system. So first similarity measure is cosine similarity. So this is the formula for finding the similarity between two vectors using cosine similarity. The formula is given as cosine of x, y is equal to summation I equals to 1 to n xi multiplied by yi divided by summation I equals to 1 to n xi square plus summation I equals to 1 to n yi square. So this is the formula for finding the cosine similarity between these two vectors, where xi and yi are the vector elements of the vectors x and y respectively. So I hope the formula is clear to you all. Now this cosine similarity is basically best when the data has high dimensional features present in it. This similarity measure is suitable for the continuous as well as the ordinal features, which means when the elements in the vector are not discrete, then also this works well. This is insensitive to the scale and magnitude of the features that are present inside the vector. Apart from this, the another advantage is that it captures the direction, and along with that it also captures the magnitude of the similarity. that is present between the two vectors. The output of this similarity measure will always be lying in between -1 to 1. So these are some of the important points that you need to consider as well as remember when it comes to cosine similarity. So I hope it is very much clear to you all. Now let's move on to another similarity measure, which is called as Jaccard Similarity. So again, for finding the Jaccard similarity, we have a specific formula. So for finding the Jaccard similarity between the two vectors x and y, we have the formula as the intersection between x and y vector divided by the union between x and y vector, where the formula for finding the union between x and y vector is the vector x plus the vector y minus the intersection of the vectors x and y. Here, the intersection of the vector x and y is nothing but the common element score that are present in both the vectors. In place of vector x, you need to write the total number of scores or elements that are present inside the vector x. And in place of vector y, you need to write the total number of scores or elements that are present in the vector y. So by filling all the values, you will get the Jaccard similarity. Now to be honest, this Jaccard similarity is not much effective when it comes to content-based recommendation systems, because we might have continuous data. But Jaccard similarity is meant to work with only binary values. For example, presence or absence of any particular feature in that particular vector. Here, it also ignores the magnitude or the value of the interactions that are performed. And finally, the output that you get from this Jaccard similarity formula will be ranging between 0 to 1. That is, the similarity values will be ranging from 0 to 1. So it is always recommended to use the cosine similarity instead of Jaccard similarity measure when it comes to content-based recommendation system. I hope it is clear to you all. Now let's have a look at the advantages of content-based recommendation system. So first advantage is that it does not rely on historical user item interactions. That means it is going to only prefer the current user's interest and not the other user's interest that has already interacted with the same video. Another advantage is that it can make recommendations for new or unpopular items, because here the recommendations are not made based on the popularity of that particular item, but it is made just because of the user's preference as well as the user's input. And most importantly, the biggest advantage is that only user's preference will be considered in this particular case. So these are the advantages of content-based recommendation system. Now let's have a look at the disadvantage of it. So first disadvantage is that it is difficult to provide recommendations for new users, because for a new user there is no historical data that is present inside the user profile or user vector, and therefore it is difficult to recommend anything that user has interest in. So this is one of the biggest disadvantage. Now as you know, this content-based recommendation system runs because of the preferences of the user. But let's say if a particular video is on trend on social media or any other platform, that trending video, which is loved by most of the people in the world, will not be shown or recommended to the user because the user doesn't have any keyword that is related to that particular trending video. So this is one of the major disadvantage. Next disadvantage is that the content description is very much needed. Now this is needed because we need to extract the important keywords or features from that particular item, and for that, if the description is not present, the keywords won't be extracted. Hence, description is must. So these are some of the drawbacks of the content-based recommendation system. I hope that it is clear to you all. If you want a video on collaborative filtering, then do comment on this particular video. For now, like, subscribe and share it with your friends, and don't forget to follow me on Instagram. Thanks a lot for watching. Have a good day ahead.